Hi everyone, thank you so much for attending this presentation. My name is Milad Mousavi and I'm a PhD student at the University of New South Wales, Sydney, Australia. I'm working under the supervision of Dr. Xuesong Shen and Dr. Binghao, and in my research, I'm trying to develop an online safety risk management system for underground industries using Bayesian networks and IoT technologies. Well, the future picture of the underground construction and mining industries is not very promising. On one hand, the global economy is extremely volatile. The prices are changing dramatically. And on the other hand, these industries are dealing with the issue of huge productivity loss. And on top of these issues, there are always some hazards and risks which are inherent to underground environments. Poisonous gases, rock bursts, subsidence or settlement are only some of the examples of these hazards. These types of risks are all very complicated in nature. But when it comes to the risk assessment methods used in the underground ecosystems, you will still see a huge gap between the intricacy of these risks and the capabilities those methods are supposed to bring. Well, for one thing, most of these methods are pure passive and static. They can only be used for a fixed time interval or in a fixed location. The other problem is that despite having advanced monitoring technologies, the huge volume of data generated is being wasted without proper processing. So, with all that, there is a huge demand being raised for innovative safety solutions for both of these industries. In reviewing the literature, I started up with the topic of safety risk management methods. Many different techniques are being used for this purpose in underground environments. First of all, there are qualitative methods like Delphi's method, and then there are quantitative methods like fault tree analysis and most recently even AI algorithms. Bayesian networks are also a common tool for risk assessment. According to definition, Bayesian networks are graphs that are usually used for modeling probabilistic relationships among a set of variables. So at a very basic level of a Bayesian network, imagine we have only two events, event A and event B. And event A is dependent upon event B by a conditional probability. In case of discrete variables, this conditional probability is usually represented by a conditional probability table, which is something like this. And it relates the different states of event A to the different states of event B probabilistically. Well, here is a more complicated version of a Bayesian network, which was developed for gas explosion in underground coal mines. In order to use this network, you need to feed it with deterministic and absolute evidence, like this example. As soon as you do so, the probabilities of all the other nodes will be updated automatically. So you can see the updated probabilities of the explosion itself, or you can track the most likely causes or consequences of that. It is also a hot topic in the literature to create a real-time risk monitoring system for underground environment, and IoT is the most common tool for that. An IoT system is basically a network of smart sensors which collect data from an environment and transmit them to a data storage for later processing, like this example that used IoT to collect settlement data in a tunneling project with the purpose of settlement monitoring and even prediction. But all the methods that I have reviewed fail in either analytical capability or the ability of real-time assessment of risks. So the intention of our research is to develop an online safety risk assessment system for underground environments. This system will be proactive, it will predict accidents before happening, it will be dynamic, it is real-time, it will be remote, and it can be used for monitoring the risks, analyzing them, and even controlling them all together at the same time. Here's a general overview of the methodology that I conducted. It starts on the left side of the screen, in the physical side, by implementing a perception layer which consists of some IoT sensors to collect data. Then the raw data will be transmitted to a data storage to be pre-processed in the second module. In this module, the time series data will be processed according to some specified thresholds and regulations to see whether the measurements are in the series condition or at the normal state. At the same time, a Bayesian network of the risks will be developed in the third module. Then the processed evidence will be fed into this Bayesian network. The results of the network will then be the predicted risks which help the operators and safety managers in their decision making. We implemented this methodology on an open source methane concentration dataset to analyze the risks of methane explosion in underground coal mines. The dataset was collected in an underground coal mine in Poland in almost 3 months. It has different attributes like wind speed, temperature, and methane concentration, and many more valuable environmental features from different locations in the case coal mine. A Bayesian network was also created based on methane explosions using Gini modeler. We mostly used the information and data found in the literature to develop this network, and it is yet to be validated by expert knowledge. It consists of different categories of nodes, for example, ignition, gas accumulation, ventilation condition, and mining activity, which all lead to the explosion node and then its consequences afterwards. In the next step, the real-time measurements of every 10 minutes of 2 of the available sensors were fed into the developed Bayesian network. The red circle here indicates the values of one of the methane concentration sensors installed at the return side of the working face. And the green circle represents the value and location of one of the wind speed sensors. After triggering the Bayesian network with every 10 minutes of data, the predicted risks of the methane explosion was calculated and drawn at this diagram. So as you can see, the case coal mine that we studied was happily pretty much safe in terms of the methane explosion in the duration of the data collection. To conclude my research, well, first of all, we proposed a real-time risk assessment framework for underground safety risks, and we tested this framework on a real case study of an underground coal mine to showcase the applicability of it. By implementing this method, I believe at the very minimum level, the safety of underground workers and personnel will be enhanced. First, by capturing the tacit knowledge of safety experts and modeling it into a Bayesian network. And second, by using real-time IoT data as the input to that model. For future work, enhancing the reliability of the Bayesian network can be the first topic. Then the values of other sensors like atmospheric pressure can also be used to get more accurate results. And finally, I believe there is a huge opportunity for this method to be combined with 3D models and the growing digital twin to advanced visual risk assessment. Here's the contact information of my supervisors and me. We'd be happy to talk if you have any further questions about this research in the future. Well, thank you so much for your attention today. I'd wish you enjoy the rest of the conference events.